What if, at this very moment, the most dangerous star in our galaxy collapsed? Would we feel anything, or would the universe simply erase us without a trace? Astrophysicists have kept their eyes on it, gathering every signal and clue, trying to predict its fate. But the truth is unnerving. No one knows exactly when, or even if, it will finally collapse. By the time its final warning reaches us, it may already be too late, its energy racing across the cosmos faster than we can imagine. Picture a star unlike any you have seen. It does not outshine its neighbors or glow with dazzling colors. Instead, it spins with a speed no jet engine could match, whirling countless times each second. Its true terror, however, lies not in its motion, but in its density. A single teaspoon would weigh more than the tallest mountain on Earth. Yet, even that is not the most chilling part. This star is unstable, balanced on a razor's edge between existence and annihilation. A whisper of extra mass, a touch more pressure, and it could collapse into a black hole in the blink of an eye. This is not some distant threat at the edge of the universe. This ticking time bomb is here, inside our own Milky Way, spinning relentlessly, devouring matter, and pushing ever closer to disaster. Before we can judge how near or distant this threat may be, we need to peel back the mystery. What exactly is a neutron star? Why do some become so extreme? And what makes this particular one the most dangerous of all? Should we fear this star? If its collapse were aimed at us, the unleashed energy could, in theory, disrupt the entire solar system or erase life from Earth in an instant. Yet, perhaps the greater danger is not what it might do, but what we might miss. These cosmic monsters reveal how rare and fragile our safety really is in a universe built on violence and chance. They force us to confront just how extraordinary our peaceful corner of space truly is. To answer these questions, we must journey into the heart of a dying star and witness the unimaginable forces at play. Only then can we grasp the true nature and the real risks of these cosmic time bombs. Picture an object no larger than a city, yet denser than any mountain known to humanity. Imagine it spinning hundreds of times each second, an engine forged by the universe's most violent powers. What kind of cosmic force could create something so extreme, so dangerous? It begins with giant stars, each one dozens of times heavier than our own sun. Their lives end not quietly, but with an explosion, a supernova that rattles the fabric of space itself. When their fuel is gone, gravity crushes the core into a shrunken, ultra-dense remnant, a neutron star. But some neutron stars are even stranger. Instead of turning lazily like Earth, they spin at mind-bending speeds, hundreds of times every second. As they whirl, these stars shoot beams of radio waves and X-rays into space. We call them pulsars, cosmic lighthouses whose flashes are so regular and precise, early scientists wondered if they were messages from alien civilizations. To grasp the madness of this, envision a sphere only a dozen miles wide, yet weighing more than our entire sun. Scoop out just a teaspoon from this star, and it would outweigh every skyscraper in New York City combined, over 1 billion tons compressed into a tiny handful. Dropped onto Earth, that teaspoon would bore straight through the crust, barely slowing until it struck the planet's core. But there is a limit. As these stars feast, their mass edges closer to a catastrophic threshold. With every stolen atom, they approach a breaking point. Just a little extra weight, a hint more pressure, and the neutron star will collapse inward, disappearing into a black hole, ending its story in utter silence. Pulsars never seem to miss a beat. Their timing rivals the accuracy of atomic clocks. Yet the tale grows darker. Some neutron stars refuse solitude. Locked in a deadly embrace with a companion star, they siphon matter in a violent process called accretion. As the pulsar devours its partner, it spins ever faster, gaining mass and energy. These are known as black widow pulsars, named for spiders that consume their mates. Yet the universe saves its wildest trick for last. Some neutron stars, called magnetars, wield magnetic fields so intense they can rip molecules apart and unleash storms of deadly radiation. Stray too close, and your very atoms would disintegrate before you realized it. These are magnetic monsters, threatening even from afar. How did this cosmic giant come to exist? And what secrets does it hold about the fate awaiting the most extreme stars? Let's trace its path from violent birth to the brink of annihilation. Studying neutron stars, pulsars, and magnetars is not just a matter of cosmic curiosity. These are nature's engines of destruction, and their existence forces us to rethink what is possible in our universe. Their power and instability highlight the delicate calm of our own world. Surviving anywhere near such an object is almost impossible, reminding us how precious our planet's gentle stability truly is. Now, let us shift our focus to a true cosmic record breaker, the fastest, most massive neutron star ever found, hidden within our own Milky Way. Its journey toward disaster challenges everything we believed about dead stars. Its story is a warning from the edge. What happens when a star pushes itself to the brink, daring to break the very forces that hold it together? Enter PSR 0952-0607, the most extreme pulsar yet discovered. This cosmic engine completes more than 700 revolutions every single second, packing almost 2.5 times the mass of our sun into a sphere barely the size of a city. To put it in perspective, a single spoonful of this matter would outweigh a mountain on Earth. Should collapse occur, it would be absolute and final. There would be no flash, no fireworks. Instead, the regular pulses we track from Earth would simply cease, erased in an instant. Yet all of this drama is playing out unimaginably far away, not just in distance, but in time. The light and radio waves we receive from PSR J0952-0607 began their journey 14,000 years ago. What we witness are only echoes from the distant past. But why is this pulsar so close to oblivion? The answer? It is not alone. PSR J0952-0607 is locked in a relentless duet with a white dwarf companion. The pulsar is cannibalizing its partner, siphoning matter and spinning ever faster as it grows heavier. Each stolen atom pushes it closer to the critical threshold, the point of no return. This cosmic feeding happens quietly, invisible to our eyes, yet astronomers know what hangs in the balance. Yet speed is only half of its story. PSR J0952-0607 is teetering on a razor's edge between survival and total collapse. Physics sets a hard ceiling on how massive a neutron star can become. Cross that invisible line, and gravity seizes control. The star implodes instantly into a black hole. There is no warning, no grand explosion. One moment, the pulsar's radio heart beats, the next, only silence, and a black hole, newly born, takes its place in the universe. But let's twist the thought experiment. What if one of these cosmic engines wasn't safely hidden on the far side of the galaxy, but lurking just next door? But not all neutron stars are so quiet in their violence. Some announce their instability with cataclysmic force, magnetars, the universe's most magnetic beasts. Could such a disaster ever threaten Earth? Theoretically, if a newborn black hole aimed focused gamma-ray jets directly at us, the radiation could sterilize our planet. But the odds are staggeringly low, almost infinitesimal. The real risk lies elsewhere, in forgetting what these cosmic cataclysms reveal about our own existence. They remind us how fragile and how rare the conditions that make Earth safe truly are. Among neutron stars, there exists a breed stranger and far more lethal than conventional pulsars, magnetars. These are neutron stars with magnetic fields so intense they are 1,000 trillion times stronger than Earth's. Even if you stood 1,000,000 kilometers away, their magnetic wrath could instantly erase your credit cards, corrupt electronics, and scramble the atoms in your body. Move any closer, and the field would shred molecules, tear atoms apart, and make the chemistry that underpins life utterly impossible. Fortunately, the universe is staggeringly vast, and the odds of such a close encounter are almost beyond imagination. Yet neutron stars do not linger quietly. They rocket through the galaxy at breathtaking speeds, sometimes over 1,500 kilometers per second, hurled away from their birthplaces by the ferocity of their birth supernovae. They are cosmic cannonballs, darting through space faster than nearly any other star. But magnetars do not simply brood in silence. Sometimes, their contorted magnetic fields snap, unleashing flares of pure energy so fierce they can be detected across the entire galaxy. In 2004, a single flare from a magnetar located more than 50,000 light-years away bathed Earth in radiation, overwhelming satellites and disrupting our ionosphere. If such a flare erupted much closer, the consequences would be catastrophic. Earth's ozone layer could be stripped away in seconds, exposing the surface to a deadly flood of cosmic radiation. In an instant, life as we know it could be snuffed out. No warning, no escape. Now imagine, by some cosmic mischance, a neutron star, or worse, a magnetar, wandering into our solar system. These objects are not just dangerous because of their radiation, their gravity is apocalyptic. A typical neutron star squeezes more mass than our sun into a sphere just a handful of kilometers wide. If one drifted near Earth, its gravity would pull at our planet with irresistible force. Oceans would boil, the crust would crack and melt, and everything living would be sterilized in a matter of hours. The devastation would dwarf every disaster in human memory. Nothing would remain but smoldering ruins, swept clean by a cosmic engine indifferent to our existence. On any given day, the danger to Earth from a stray neutron star or magnetar is negligible, but the stakes are ultimate. A single encounter could erase not only humanity, but the entire planet, without warning, without hope. It is a reminder of how fragile our safety truly is, and how fortunate we are to occupy this quiet, sheltered corner of the universe, far from these cosmic monsters. Still, despite their dangers, these stars are not just threats. They are also windows into the universe's most extreme phenomena. And by studying them, we learn not just about their violence, but about our own improbable safety. How can something as delicate as a planet survive in the shadow of the universe's most violent stars? The truth is far stranger and more awe-inspiring than it first appears. Across the entire galaxy, only a tiny handful of neutron stars ever host planets. These rare worlds exist in defiance of the odds, circling cosmic engines that could annihilate them without warning. Picture what it would mean to live on a planet like this. Each day would bring a barrage of radiation far fiercer than any solar flare humanity has ever witnessed. The sky would pulse with relentless energy, and even the smallest misstep in orbit could spell instant destruction. For life to emerge, if it ever could, it would need protection beyond anything found on Earth. Thick layers of shielding, perhaps entire cities buried deep underground, forever hiding from the lethal beacon overhead. How do such impossible planets come to be? Some are forged from the ashes of a supernova, built from the dense, chaotic debris left behind when a giant star dies. Others are the shattered remains of companion stars, torn apart and devoured until only planetary rubble remains. A few may have drifted too close, snared forever by the pulsar's gravity. Yet every one of these planets shares a single fate. Somehow they persist in a world of chaos, drenched in deadly radiation and pounded by wild, unpredictable gravity. What does this reveal about us? Our own solar system's gentle calm is a cosmic exception. Most planets across the universe face extremes. tidal forces that tear them apart, radiation that sterilizes their surfaces, or gravitational chaos that makes stability impossible. Earth's habitable zone is not typical. It is staggeringly rare. Seen through the lens of pulsar planets, our planet is not merely lucky, it is almost impossibly blessed. So, after all this, is there a reason to worry? Let's finally confront the question that began our journey. Not every star is a friend, but learning their stories casts our own in a sharper light. The answer is more nuanced than you might expect. It reveals both new dangers and new reasons to marvel at where we are. Examining the lives of these dangerous stars is more than a scientific curiosity. It reminds us how fragile and extraordinary our own situation truly is. Awareness of the risks lurking in the cosmos sharpens our perspective, grounding us in humility and deepening our gratitude for the precarious balance that sustains us. To ignore these cosmic hazards would be to blind ourselves to the extraordinary luck that shelters us, and to forget that the universe is designed for extremes, not for comfort. After our long journey through the galaxy's most extreme stars, it is natural to wonder, should we fear them? Pulsars, magnetars, and their even stranger kin are cosmic engines fueled by unimaginable energy. Their violence is real, but for us, their reach is remote. The odds that a neutron star, no matter how fast it spins or how fiercely it feeds, would ever threaten Earth are astronomically tiny. The universe stretches across distances so vast that even the most chaotic stars are insulated from us by billions of kilometers. These are not threats lurking in the dark, but warnings of what is possible elsewhere. Knowing these extremes exist humbles us. The universe is not designed for safety. It is a realm of violent birth, collapse, and transformation. Our world is a fragile oasis, floating in an unpredictable cosmic sea. This is not a guarantee, but a gift. Oh, yet something precious is truly at stake. Our perspective. By coming face to face with the density of neutron stars, the insatiable hunger of black widow pulsars, and the fierce magnetars, we glimpse how rare our gentle cosmic neighborhood really is. For every sun-like star, there are rare monsters that twist the laws of physics and remind us how extraordinary calm and stability can be. Learning about the galaxy's most dangerous stars should not make us afraid. Instead, it should ignite awe, curiosity, and appreciation, a deeper hunger to understand the universe and our own place within it. The more we discover about these cosmic beasts, the more we realize how unlikely and precious normal truly is. So next time you gaze upward, remember our existence is not just probable, but miraculous. We thrive in the steady glow of an ordinary star, sheltered from wild forces that rage elsewhere. Out there, in the darkness, are objects stranger, faster, and more powerful than we can imagine. Each discovery about them is another reason to marvel at our improbable safety, and another invitation to keep searching for answers in the great unknown. Now, let us deepen our exploration and lengthen our script with historical parallels, concrete examples, scenarios, and practical steps we could take as a civilization to better understand, monitor, and even prepare for the cosmic violence that lies beyond our sky. If our journey so far has been a tour of the galaxy's most dangerous stars, let us now add layers, stories, comparisons, and the hard-earned wisdom of science throughout the ages. Imagine the impact if a neutron star collapse or magnetar flare were to occur much nearer to us, say within our galactic neighborhood. We can draw a parallel to the Great Tunguska event of 1908, when a mysterious explosion, likely caused by a small asteroid or comet, flattened thousands of square kilometers of Siberian forest in a single moment. If a gamma-ray burst from a nearby pulsar or magnetar ever struck Earth, the devastation on a global scale would make Tunguska's destruction look like a mere firecracker. Let's take a closer look at real events. In 2004, as previously mentioned, a magnetar known as SGR 1806-20 unleashed a flare so powerful that despite its distance of more than 50,000 light-years, it affected Earth's ionosphere. Consider that energy. In a fraction of a second, the magnetar released more energy than our sun emits in 100,000 years. If such a flare happened within a few light-years, satellites would be fried, global communications would collapse, and the surface of our world would be bathed in lethal radiation before we even grasped what was happening. Historically, humanity has often learned of threats from space only after they have occurred. The Carrington event of 1859, the largest solar storm ever recorded, set telegraphs ablaze and ushered in auroras as far south as the Caribbean. If a powerful solar storm can cause such chaos, imagine the effect of a magnetar flare 1,000 times more powerful. Our entire electric grid, modern infrastructure, and digital communications could be obliterated in the blink of an eye. What's more, gamma-ray bursts, those short-lived, ultra-energetic events, are believed to have caused at least one mass extinction on Earth. Around 440 million years ago, during the Ordovician period, evidence suggests that a nearby gamma-ray burst may have stripped away the ozone layer, exposing the planet to deadly ultraviolet radiation and plunging life into crisis. This is not just science fiction, it is written in the rocks beneath our feet. Realistically, what could we do if we spotted signs of impending doom from a nearby neutron star or magnetar? The first step is vigilance. Our instruments, radio telescopes, X-ray satellites, and gravitational wave detectors must be kept vigilant, searching for the telltale signals of instability or collapse. Projects such as the Square Kilometre Array and the Laser Interferometer Gravitational Wave Observatory, LIGO, are already revolutionizing our ability to detect and analyze cosmic threats. Suppose, in a future not so distant, our telescopes detect a sudden drop in the pulses from a neutron star, accompanied by a burst of gravitational waves. That would be our only warning, a cosmic siren. In response, space agencies could ground flights, shut down satellites, and instruct populations to seek shelter underground. While this would not save everyone, preparation could be the difference between extinction and survival for at least some. Throughout history, societies have responded to existential threats by building resilience. During the Cold War, the possibility of nuclear war led governments to construct fallout shelters, stockpile food, and devise contingency plans. In the face of cosmic dangers, similar measures, underground bunkers, radiation shielding, robust backup systems, could be our insurance policy against the worst the universe has to offer. But this is not just about preparing for disaster. The study of neutron stars, pulsars, and magnetars has already yielded extraordinary discoveries. For example, the precision of pulsars has enabled astronomers to test the predictions of Einstein's general relativity with unmatched accuracy. The Hulse-Taylor binary pulsar, discovered in 1974, provided the first indirect evidence for gravitational waves, ripples in spacetime that confirm the dynamic nature of the universe itself. Magnetars, meanwhile, have inspired new technologies on Earth. The intense magnetic fields they generate have led physicists to explore new states of matter and develop novel materials with applications in medicine and electronics. The study of gamma-ray bursts has driven innovation in satellite design, ensuring that our detectors are hardened against intense cosmic radiation. As for practical steps, international cooperation is essential. Astronomers across the globe must share data rapidly, coordinate observation campaigns, and pool resources to track and interpret the behavior of dangerous stars. Just as nations have banded together to monitor asteroids and comets, so too must we unite to keep watch over the cosmic engines that threaten from afar. Yet, the very act of preparing for cosmic threats can have unexpected benefits. In building robust infrastructure, we protect ourselves not just from neutron stars, but from more mundane disasters, solar storms, asteroid impacts, even nuclear war. The pursuit of knowledge, the drive to understand and anticipate the universe's dangers, strengthens our civilization in countless ways. Consider a scenario where we discover a neutron star on a collision course with the solar system. The odds are minuscule, but the consequences are ultimate. Such a star, moving at hundreds of kilometers per second, would be unstoppable by any technology we possess. Our only choice would be to prepare for impact, seeking refuge underground, storing genetic material for possible future resurrection, and beaming messages into space in the hope that intelligent life elsewhere might learn our story. Let's return to the psychological impact of cosmic awareness. Throughout history, every time humanity has glimpsed the true scale of the universe, it has changed us. When Galileo first turned his telescope to the heavens in 1609, he shattered the illusion that the cosmos revolved around Earth. The discoveries of Copernicus, Newton, and Hubble each forced us to rethink our place in the universe. So too does the study of neutron stars. By confronting the reality of cosmic violence, we are forced to grapple with our own vulnerability. And in doing so, we discover the value of our fleeting existence. In such a moment, public outreach and education would be critical. Scientists would appear on television and online, explaining the odds, the science, and the steps being taken. Schools might hold special lessons on neutron stars. Museums could host exhibitions on cosmic dangers. The event would inspire a new generation to study physics and astronomy, to seek answers to the universe's deepest mysteries. There are also lessons to be drawn from religious and philosophical traditions. Many ancient cultures told stories of gods and monsters in the sky, reflecting humanity's awe and fear of celestial events. The Norse spoke of Ragnarok, an end time triggered by cosmic forces. The Greeks imagined the heavens as the realm of capricious deities. Today, our understanding is scientific, but the sense of awe remains. Neutron stars and magnetars are the new titans, unfathomable, powerful, and indifferent to our hopes and fears. Let's imagine a practical scenario. Say, a newly discovered pulsar in our galactic neighborhood begins to show signs of instability. Astronomers issue alerts, and scientific teams scramble to model the possible outcomes. Would it become a magnetar, collapse into a black hole, or simply fade into silence? The world watches as data pours in, social media buzzes with speculation, and governments quietly consult their emergency protocols. The event becomes a global moment, a reminder that, despite our divisions, we share a common fate. In the end, the lesson is not to live in fear, but to live with awareness. The universe is not hostile, but it is indifferent. Our safety is not guaranteed, but it is real, and it is rare. Let's not forget the artistic response. Throughout history, disaster and wonder have inspired great works of art. Painters, writers, and musicians might create works that capture the tension and beauty of a universe where annihilation and creation are two sides of the same coin. Documentaries would chronicle the unfolding events, while fiction writers would imagine worlds where neutron stars loom in the sky, reminding us of our own stories and hopes. On a more personal level, becoming aware of cosmic dangers can change how we live day to day. For some, it brings anxiety, a sense of helplessness in the face of overwhelming odds. For others, it brings perspective, a reminder to savor life, cherish relationships, and find meaning in each moment. The knowledge that everything we love is balanced on a cosmic knife edge can make our joys and sorrows feel all the more precious. There is a final practical step we can all take to support science. Funding for observatories, satellites, and research is not just for the curious. It is our early warning system, our only defense against the unknown. By supporting education, we ensure that the next generation will be ready to face whatever the universe throws at us. And so, as we look upward, whether with fear, awe, or hope, let us remember, the most dangerous star in the galaxy is both a threat and a teacher. It shows us what is possible, what is rare, and what is precious. It challenges us to unite, to learn, and to dream. In the cosmic lottery, we have drawn a winning ticket, a planet that orbits a gentle star, far from the violence of neutron stars and magnetars. This is not our right, it is our luck. Every day we wake to sunlight, Every night we gaze at a calm sky is a day to be grateful, a day to wonder, and a day to prepare for the mysteries yet to come. Our journey is not over. The universe is vast, wild, and unpredictable. But the more we know, the better we are prepared. Let us keep watching, keep learning, and keep dreaming beneath the sheltering sky. So the next time you look up at the night sky, remember, beyond the stars you see, hidden in the darkness, are cosmic engines spinning, pulsing, and waiting. Their stories are not just warnings, they are invitations to search, to learn, to marvel, and to cherish the fragile miracle that is our home.